Thank you so much for the intro, and thank you for being here. My name is Gianluca Mardente. I'm a principal engineer at Cisco. I work in the App Dynamics business unit. My talk today is about how we use Kubernetes to manage a fleet of Kubernetes clusters. Essentially, it's just like our journey. We started like a few years back, and we started with a few clusters. And now what kind of problem we faced when we want to scale the number of clusters that we managed, and the number of applications that we want to manage, like on every cluster. So, as we all know, Kubernetes is the container orchestration platform. Everybody uses it. We use it. We do have a lot of clusters. Some are on cloud. Some of those clusters are on-prem. And as I mentioned, when we started like a few years back, we started like with few clusters. But from the very beginning, it was clear to us that if we wanted to scale the number of clusters and if we want to scale the number of applications that we manage on those clusters, we need to have, we could not manage those clusters individually. We had to have like a way where we could programmatically express our intent. So we set a few goals. And the main goal for us was we want to define with a policy what our cluster is supposed to be, how many clusters we want, how many nodes we want in every cluster, what kind of application we want in every cluster. And we wanted a system that was able to keep reconciling and bring those clusters to the expected state. So that sounds like very familiar if you have written like a Kubernetes controller. That's what pretty much they do. You pass them like you tell it what your cluster is supposed to. You tell it what your intentions are, and the controllers move like toward reaching your goals. And we want also a system that can automatically detect a response to a variety of events. So we started with a Kubernetes clusters, which we use as a management cluster. And from this central place, we want to be able to create clusters, upgrade clusters, delete clusters, deploy applications, delete applications, upgrade applications. So the first question is now, if you have a Kubernetes cluster, can you programmatically create other clusters from this management cluster? And the answer is yes. There are like a variety of tools available today. Cluster API is one of those. Cluster API is just a set of customer source definitions and a set of Kubernetes controllers. You express what your cluster is supposed to look like, how many control plane nodes, how many worker nodes, the version, and it creates like a cluster for you. It's one of the tools available. It's not the only one. There are many other tools. Personally, I've used also Claude. The main difference between Claude and Cluster API is that with Claude, pretty much you can create a cluster and you can have like nodes which are in different clouds and still part of the same cluster. But we do use like Cluster API for our goal. So with Cluster API, essentially you can create a cluster, upgrade a cluster, delete a cluster, but once you have a cluster, is that done? It's like the answer clearly is no, because once a cluster is created, now you have to start deploying add-ons. You need like a CNI, and you start deploying applications. At the end, the reason you created a Kubernetes cluster is to run your own applications. And when dealing with add-ons and applications, sometimes it's very easy to say what you want, because you simply list the things, the add-ons and applications that you need. There is no dependencies between those, and you're simply like deploying. It's like, okay, this is the list that I need, and those things can be deployed from the management cluster to the managed cluster, and you're done. But most of the time, there are dependencies. And those dependencies like are different, because sometimes you simply, one dependency may be that your application, you're deploying an application which needs a customer source definition to be present at the time the application is deployed. So there is no state involved. You can simply deploy, install your customer source definition, and as soon as that is done from the management cluster, you can move forward and deploy your own applications. Other times, things are a little bit more complex, because your application you may have an application B, which depends on an application A, but your application B can only be installed when the application A is in a given state. So now at this point, before you deploy the application B, you have to have a system that is capable of understanding application A has been deployed, and application A has reached like this given state. And so this is the right time to go ahead and deploy application B. Other times, like things are even a little more complex, because Your application might depend on things which are outside your cluster. For instance, you are deploying an application which needs a database, and for whatever reason, you decided that you want to use one of the cloud-managed database. So now, before you deploy your application, you have to go wherever, like wherever like your cloud provider is, instantiate your database, get all the information that are needed for your application to access the database, and only when you have, like, when your database is up and running in the cloud and you have all this information, now you can go ahead and deploy your application in your Kubernetes cluster. So this is just like a recap of the different type of dependencies that we may have. A simple case is we have like a management cluster in this case, from where we are managing a fleet of clusters. And we do have like 2 workload clusters. One is labeled environment functional verification, another one is labeled environment production. And for instance, what you want to do, you want to deploy Prometheus and Grafana in the cluster which is labeled with, which has the label environment functional verification. But you have like no state that you need to look at. You simply want to deploy first Prometheus, and when the Helm chart of Prometheus has been deployed, go ahead and deploy the Grafana Helm chart. So you simply express your intent, and what the system does, it deploys Prometheus, and as soon as Prometheus is deployed, it goes ahead and deploys Grafana in the cluster pretty much that has the right set of labels. So this is one easy use case where you simply list what you want, and those things are deployed one after the other from the management cluster. But a more complex case, it's when you want to look at the state. For instance, you want to deploy a Postgres database in your cluster, and then before you move forward, you need to wait for your Postgres database to be up and ready, because that's only at that time you want to deploy like a job that goes and creates a table in this database. So before you run the job, now the database needs to be up and running. So you need to be able to define what up and running means. And you need to be able to detect that state. And you know, keeping forward, like in this example, you have to wait then for the job to complete. And only when the job completes, you go ahead and deploy like a to-do app. And only when the to-do app is up and running, you go ahead and deploy like another job that creates an entry in the database. This is one of the typical examples that you can find like in the Kubernetes documentation when you're looking like for a system that depends on state. And so how do we express that one? Well, the first thing is like, deploy the Postgres database. That's simple, right? You want to deploy the Postgres database, you simply say where you want to deploy, and the Postgres database gets deployed. But once this is deployed, now you have to look for this to be up and running. So you need to be able to express your state machine and saying, my Postgres database needs to be healthy, and healthy in this case might mean simply like that the number of expected replicas, active replicas are matching the number of expected replicas. And so we deploy also, you need an agent which is running in the managed cluster that needs to be able to do 2 things. One needs to be able to be programmatically instructed on what type of events it needs to look for. And in this case, the events that it needs to look for is that the Postgres database, it's up and running. All its replicas are healthy. And it's able pretty much to be programmatically instructed what to look for and detect those events. And when it detects those events, you can go ahead and notify the management cluster. Then I've seen these events, so this state, it's green. And at this point, from the management cluster, we can move forward to the next step, which is to deploy the to-do app. So this gets deployed. And again, at this point, once we deploy, we have to instruct the management, the agent in the managed cluster, that he has to wait for the job to be completed. And again, like if you see, it's like now the definition of event is different. Before we were looking for the deployment replicas to be healthy. Now we are looking for a job to be completed, which means that this agent here must be programmatically instructed on what to do and should be able like to detect all those events. So should be able to watch at every Kubernetes resources which is present in the cluster, and should be able to detect, look at the state, look at the status, look at the spec, and detect pretty much when these events is completed. And when this event is completed, you know, like again, it notifies the management cluster, and the management cluster move forwards, installing pretty much the to-do app, and this to-do app is simply going to access the database. And again, we have to tell the agent in the manager cluster what the event is, like wait for this to-do app to be up and running. and so on. So the cycle repeats till pretty much we are done like building the everything that we want to build. So in this case, in the management cluster, we define like a state machine, and we move from one stage of the state machine to the next one with the help of the agent that is running in the management cluster. And the agent should be able like to be programmatically told what an event is and detect those events. So this is done. Now, once you're deploying, another problem that you have when you're deploying a bunch of applications in a fleet of clusters, is that very likely you're going to deploy the same application in different clusters with little bit different configuration. One example will be you have an application that you want to test, so you deploy like this application in your testing cluster, and when you're deploying your application in your testing cluster, very likely you are testing the functionality of your application, so you're not very much worried about the scalability. So you deploy your application with a replica set to 1. But when you go in production, now the scalability and you want your application to be highly available, so you set like a different replicas, which is 3, 5, whatever like makes sense for your application. Now, in this case, you do have, this information up front, and so you can use tool like Customize to deploy the same application with a little bit different configuration in different clusters. And this is like it's an easy use case to solve, but the complex use case is when you do not know like those values up front. For instance, you may want to deploy an application that needs to collect data in the cluster and uploads those data to a bucket. Now, you don't know the bucket URL upfront, because you know that you have this application that is supposed to collect information and send to a bucket, but you're going to deploy the bucket at the time just before your application is deployed. So you do not know like those information upfront. So how can you solve this case here? To solve this case here, you have to be able to define your application as a template, and you need to be able to instantiate this template using information which is coming from the management cluster or the managed cluster at runtime, because you do not have like this information up front. So I have like an example here, which is an end-to-end example. So we have a management cluster where we have Cluster API running in the management cluster, and we want to create a Kubernetes cluster. So what we do, we post the Cluster API custom resources, and Cluster API is going to create the cluster as we wish. As soon as the cluster is created, now what we want to do, we want to deploy this application, which is supposed to collect whatever data in your managed cluster and upload to a storage bucket. But we want to create one bucket per every instance of the application that is deployed. So because we are deploying this application in this cluster here, what we want to do first we want to create the bucket. And to create the bucket, for instance, in this example here, I'm using Crossplane, so I'm posting like a Crossplane bucket instance. And as soon as pretty much this Crossplane bucket instance is created like in the management cluster, Crossplane goes and create the bucket in whatever like cloud provider you decide to create the storage bucket. Now, when Crossplane is done creating the bucket, now the bucket instance status gets updated. And it contains information that are needed to access the storage bucket. For instance, it contains the storage bucket URL. Now, at this point here, what the system is supposed to do is supposed to take your application, which was expressed as a template, where the bucket URL was a template parameter. It's supposed to take the storage bucket, gets this storage URL from this resource, which is present in the management cluster. It's supposed to instantiate your application using this information, and then you can go ahead and deploy this information. Once your application now is deployed in the bucket, it has all the information to do its job, collect information and send this information to the, upload this information to the bucket that you just created. In this case, pretty much because you do not have like this information up front, the only way that you are left is to define your application as a template and need to be able to instantiate this template using information which is present in management cluster at the time of deployment. Now, if we have looked at how to create cluster programmatically and how to deploy applications programmatically, but we have to consider that we have likely two different types of clusters. We have like short-lived cluster and long-lived cluster. When we are dealing with short-lived cluster, all we need is to be able to consistently create those clusters. So velocity and consistency is the main factor. And what we have discussed so far pretty much covers like everything that we need. Because like if I'm able to consistently create the same cluster over and over again, then I'm done. But when I look at long-lived cluster, now there is a different set of problems that we need to take care of. With long-lived cluster, you need to be able to upgrade your cluster, because sooner or later, pretty much the Kubernetes version that you're running in your cluster is outdated, and you have to move like to a newer version. Or you have to upgrade your own application, because like you release like a new version of your application, and you need to worry about like how can we do those things here. If you're dealing with a fleet of clusters, also very likely you have different type of admins, because like nobody can have like full knowledge of all the applications that are running, and so you have very likely a platform admin that is in charge of maybe the Kubernetes version, and you have different type of admins, which are application admins, everyone in charge of a subset of the applications. Now consider the scenario where you want to upgrade the cluster. You do not want all those admins to sit in a room together and decide, okay, can I upgrade your cluster? Is your application going to be okay if I upgrade this cluster? Because that will be like very likely error prone and definitely won't scale when you have to do this operation like many times per day. So what you want, it's you want to give the application admin the ability to say, if the Kubernetes cluster is in this runtime state, this is the version that I want to run. For instance, I know that I have an application, and I have like 2 versions of my applications. And I know that version 1.0 works well with every cluster which is lower than 127. And I have a version 2.0, which I know that works well on every cluster which is greater than 127, Kubernetes version 127. Now, if I allow the application admin to create those policies, and I have a system that can automatically classify a cluster based on its runtime state, I don't need like the admins to talk to each other. Because everybody expresses on policy, and when the system changes state, those policy becomes a hit, and the application gets automatically upgraded. So this is an example that, again, I have 2 clusters which are running Kubernetes version 126.1. And the application admin comes and say, in every cluster which is running a Kubernetes version less than 127, I want to deploy Gatekeeper 3.9. Now, if we do have an agent running in every cluster that can classify the cluster, this agent can say, okay, those 2 clusters here are a match for this policy. And because they are a match for this policy, I can go ahead and deploy Gatekeeper 3.9.0, because this was pretty much what the policy said. So I don't have like admins to talk to each other, just define the policy and classify the cluster based on its runtime state, and things magically happens. So what happens like if the admin now has a different version? The admin can one of the application admin might say, well, if there is a cluster which is running a Kubernetes which is greater than 127 and less than 128, I want Gatekeeper 3.10 to be running in that cluster. He puts this policy on, and then a week later, a month later, the platform admin decides that one of those 2 clusters needs to be upgraded. So for instance, the cluster one of those clusters gets upgraded from 126.1 to 127.3. Because this upgrade happens, the agent automatically classifies this cluster and says like, okay, now this cluster is not a match anymore for the previous policy, but it's a match for this policy. And this policy says that I need to deploy Gatekeeper 3.10, so the application automatically gets upgraded. So there is no coordination between the admins. It's just that we have a system where admins can express their intent, the agent can classify the cluster based on its runtime state, and the system pretty much brings like the applications to what they're supposed to be. So it deploys pretty much 3.10. And of course, pretty much like this scales very well. Once you have policy like that, you do not have like to have tenant admins talk to each other. You simply put the policy, and then you can consistently upgrade the cluster, and every cluster converges to the same state. The final scenario is that now that we have built this system where for a central place, we can create cluster, upgrade cluster, delete cluster, deploy applications add-ons, and upgrade those application add-ons, can make this available to others as well. So if we want to onboard tenant, the answer pretty much it's yes, we can, because the only things that we have to do, essentially, it's use namespaces in the management cluster. So if in the management cluster now I define a namespace for every tenant, now I can onboard every tenant. Every tenant can put his own policy in its own namespace. those policies are going to affect only the cluster that this tenant owns and manage, and it's not going to interfere with the other tenants. And so there is a central place where every tenant can do whatever he wants with his own cluster. And still, as a platform admin, I can put like policies which are cluster-wide, which are going to affect all the clusters. For instance, if I want to put a Caverna policy that says like, no image from this repository should be deployed in any of the cluster, I can still do that because I have a chance of defining a cluster-wide policy which is going to affect all the clusters. But then every tenant, it's going to manage like its own cluster, and it's not interfere with the others. And all is done programmatically. That was it. I still have 2 minutes left, roughly. So I don't know if I can take questions, if there are any questions. Okay, well, thank you so much. Then.
Okay. Well, you're going to be. Are you going to be around in like sponsor area?
Yes, I'm going to be around both today and tomorrow. So
perfect. Okay. If anybody has any questions, go ahead and find Luca. Thank you so much. Give him a good round of applause.